So the second question that we've been looking at in class is this one, where we have a rectangle, or it's a large block of land. You know, it's kilometers squared, so it's a huge block of land that we're, I guess, trying to imagine. Now, a lot of people got really caught up in this. This is the length, and this is the width. And some people got really caught up on this, the fact that the length has a variable in it. But the whole point of this question is to use some algebra and some algebraic skills in a bit of a complicated or real life situation. So we have to chuck a variable in there. If we just have 8 times 6, it's not algebra. It's measurement, straight measurement without the element of an algebra and a variable in there. So write an algebraic equation. There's that thing, that term. That really just means write a rule. Okay, write a rule to find the area of the land. So I'll write it up here. We know that area equals length times width. Okay, write down what you know. Okay, let's accept that the area is unknown, and let's also accept that in this situation our area has a variable in it, and its value is y plus 6 kilometers. So the length isn't 6 kilometers, the length is bigger than 6 kilometers because there's a value here we add on. Now I know down here it tells you what y equals. But we've been talking in class about the fact that you need to focus on the question at hand. And for some students I said, you know, if you fold this paper and pretend that question B isn't even there, okay, then you don't know that y is 4. It's just that people are reading on too much, okay, not doing the question at hand. So we have to write a rule to find the area of this land. Now there's a number of rules that you can write, but there's a purpose to this question if I can continue. Multiplied by 8. Okay, so in a test, that'd get you half a mark. In a test, that might get you some more marks because you're, I guess, personalizing this very general rule, personalizing it with the details of this particular question. So you've taken the length over and you've taken the width over. Now what we've spoken about in class is that the point of this question is to incorporate our skill of expanding, and we want you to recognize that expanding can be used in a real life situation. So when we expand, I guess the first thing we talked about is that when you multiply things you can switch, because 2 times 3 is 6 and 3 times 2 is 6. So the first thing we did to make it really clear is switch around the order of this multiplication. Like I just said, 2 times 3 is 6. 3 times 2 is 6. So if we switch this bracketed term and put it here and put the 8 at the front, we haven't changed the question, we've just changed the order of the question. So now what we start to see is that we can actually write it without the multiply, and it starts to look like what we did late last term with our expansions. So our expanding starts to get very clear in this step here, and I guess in this step here. But you've just eliminated correctly the multiplying sign, which you don't need when you expand. So when we expand, okay, just to recap, area equals length times width. The length of this rectangle is y plus 6 and the width of it is 8. What we've just done is we've just switched over the order of our terms, and we can do that when we multiply. 4 times 3 is 12 and 3 times 4 is 12. The order of those terms doesn't matter, doesn't change the value of it. So we've made the switch here. Now we start to see in these two steps that we can apply our rule of expanding, and that's what the question wants you to do. When we expand, we say multiply in whatever is outside the bracket, you multiply by whatever is inside the bracket. So if I can take this over here, area is going to become 8 multiplied by y plus, because of our plus, 8 multiplied by 6. So our rule is 8y plus 48. That's the best answer for this. That's the most accurate and thorough answer. If you did this in a test, you get half a mark, you got started. It's better than someone who didn't get started. If you write this, you know, you're personalizing this very general rule to the question. If you can recall and apply that idea of expanding, that's the best rule that we can come up with. Okay? Alright, so now what we do is we do look at question B, and we look at the fact that we get given a value for y, and we get asked to demonstrate your understanding of this question and algebra by finding the area of the land using both the algebraic rule you created in question A as well as using the standard rule for area. You really need to have the same answer, okay, for both methods. The same answer for both methods proves you fully and correctly have evidenced a good understanding of algebra if you get the same answer. So let's, it tells you use the rule from question A. So A, we ended up getting area equals 8y plus 48. And we came up with this rule by applying our knowledge of expansion or expanding. Okay, the length multiplied by the width, we switched it around because the order doesn't matter. Then we started to realize that we can multiply in. When we multiply in, we're expanding, and we end up with this. So it actually says to use use your expression from question A. Okay, and we want to compare that to a standard rule. A standard rule for area is what we started with, length times width. Okay, so what we need to do now is substitute in for our values for y, and we need to get the same answer. So area equals 8 times y plus 48. Area equals 8 times 4. Plus 48. Area equals 32 plus 48. Area equals 80 kilometers squared. Okay, so we've just multiplied by y, substituted in our 4, so we're using a number of algebra skills, and we've solved it. If we use our very standard rule without that idea of expansion, which is algebra, your length is y plus 6 times width. Area equals 4 plus 6 times the width is 8. We can substitute in by now. Area equals 6 fours are 24. 4 plus 6 gives me 10 multiplied by 8. My area is again 80 kilometers squared. So this is correct for both methods. So you need to remember the purpose of the question. The purpose of the question, firstly, is to show two different methods. A more confusing method on this side, the process of getting there, and a simpler process, but to get the same answer. Okay, so the purpose of the question is to use two different methods but to get the same answer. Okay. Another purpose of this question is that we need to see you use some algebra skills in a complex situation. One of the main skills that we want you to incorporate or use is our skill of expanding. So we use the skill of expanding to set up our rule. And then we've used a couple of other skills along the way, mainly just substitution. We had to substitute in for 4 for y, and we had to substitute in 8 for the width, etc. Okay, so two processes, same answer is one point of the question. And the other purpose of the question is that we want to see you use the skill of expanding, which is an algebra skill, in a complex situation.